Welcome everyone to Twiist Studios for our second webinar in our four-part series. Today we're going to focus on the twiist loop algorithm. So really excited that you joined us here today. Just a quick review of the agenda. We really have four key areas that we want to dive into today. The first is, for those who haven't seen, we're going to do a quick refresher on twiist, the whole system and what it's all about. Then we're going to talk about our partnership with Tidepool, our algorithm partner. And then we'll spend a little bit of time with our my esteemed colleagues here, talking about the clinical data behind Loop, so you get some insight into the results that people have seen using Loop. And finally, we'll spend most of the time talking about the practical application of the algorithm itself and how you can use that to improve clinical outcomes for your patients. And then finally, at the end, we'll do some Q&A. So please stay engaged throughout and use the function here to really enter any questions that you may have, and we'll be sure to answer them. If we don't get to all of them today, we'll follow up with you as well to make sure that we get all of your questions answered. So this is, as I mentioned, the second in a four-part series. If you didn't get the chance to see the first webinar, that's available on our website, so you can use the information on the screen to go and find that. And today, as I mentioned, we're really going to focus on that deep dive on the algorithm and the practical application. And then we'll have two subsequent webinars as well. We'll have one that's a deeper dive into the technology, and then we'll have one final session that's really about how to get started prescribing and using twiist, and all about our unique access that we have through the pharmacy channel. So with that said, I wanted to introduce myself and our esteemed panel that we have today. So my name is Chris Gilbert. I'm in charge of the marketing group here at Sequel, and I am absolutely thrilled to be part of the team that is going to bring twiist to the community. And with me today are Jean and Joanna, two of my colleagues from Sequel, and I'll let each of them introduce themselves. We'll start with Dr. Joanna Mitri.
Hi, Chris. Hi, everybody. Great to see you all. I'm Joanna Mitri. I'm an endocrinologist by training. I'm the Chief Medical Officer here at Sequel, and my role is to oversee our medical and clinical affairs. It's great to be here today, and excited to tell you more about our data and our algorithm.
And I'm Jean Jacoby. I'm a nurse practitioner and diabetes care and education specialist. I love diabetes technology, and so I'm excited that I get to be here at Sequel with this great team, and I especially am excited to share about the algorithm.
All right, so I get to do a quick introduction and refresher on twiist, and before I dive into that, I think you've all heard by now with our press release, and as well as if you had the chance to attend ATTD either live or virtually, that we have announced our first CGM partner, and I'm really excited to say that that partner is Abbott. We're partnering with their Libre Freestyle 3 Plus sensor, and so that will be our initial CGM that we use in the system, and we're continuing to look to partner with all the major CGM players out there, as we do believe in patient choice, and so we'll be continuing to expand our partnerships over time. Here's a quick view into the system. I think most of you are probably familiar with what an AID system is, but I wanted to call out a few unique differences that our system has that you may not be aware of. So the first is the twiist pump. So basically what we did is we took the algorithm that went through the FDA clearance process with Tidepool, and we translated that into a different programming language and put that on the pump itself. And the reason we did that, as you might be wondering, is really so that people could remain in closed loop mode without having their phone or their app near them. And so that's really a big differentiator that we have with twiist. Another thing I wanted to call out, as I just mentioned, our partnership with Abbott and the Freestyle Libre 3 Plus sensor. We're incredibly excited to be a partner with Abbott. It's an incredibly accurate system, and it's really something that we look forward to partnering with them on as we move forward. And the last key thing that I wanted to call out are some of the unique features that we have in terms of our system and control from the Apple Watch. So we're the only system that allows you to bolus actually from your Apple Watch. So you can bolus from your Apple Watch. You can also bolus from the on-device button here that you see me trying to highlight there. And finally, you can bolus from your app as well. So really 3 unique ways that you can bolus and control insulin delivery. So really excited to dive in a little bit further here as we move forward. But there are really 3 core things that I want to make sure that everybody walks away knowing. The first is the 3 core benefits. The first is the simplified access that we have. I mentioned that a minute ago. It's really convenient for people to really be able to get twiist through the pharmacy channel. That will allow people to start with no warranty needed. They don't have to wait for their warranty to expire. And so they have no 4-year commitment. Great, easy, streamlined way to get people started. Our goal is not just to bring a new exciting system, but also one that will provide more access to AID systems for the broader population. The second thing, and this is where we'll focus most of our time today, is on that personalized control. A lot of the features around the algorithm, as well as some of the other benefits that the system provides, to really be able to meet the needs of a broad range of your patients in your clinic. And then finally, the other thing, and we'll touch briefly on this, is that we have a really unique insulin delivery mechanism, unlike anything else that's on the market today. And really what that allows us to do is know precisely how much insulin was delivered with each pulse of insulin. With that said, we're going to dive into our unique Tidepool partnership a little bit. Some people ask, why did we choose Tidepool? And it's really because this algorithm was driven by the community, and we'll kind of talk about the evolution of how that started. But it's really this incredible groundswell of innovation that happened in the diabetes community with people who have diabetes really just looking to make their lives easier, the lives of their children with diabetes easier. And so it was an incredible groundswell of support and enthusiasm that really came from that diabetes community. And we really wanted to help bring that and make that more accessible to people across the entire diabetes community. And so when we think about that progression, it really started in the diabetes community. And some people were able to take advantage of that, but there was a lot of technology that people had to know, code you had to download, different dongles and dangles that you had to figure out how to connect. And so it wasn't necessarily available to as many people as we would like to see. So fortunately, Tidepool was able to take that algorithm, a version of that algorithm, work with the FDA to get that cleared, and then now is partnering with us so that we can bring this and make it available to the widest set of people in the community as possible. So really excited about that. And I'm sure you're a little bit curious about some of the clinical results. So I'll turn it over to Dr. Mitri to talk about our the clinical results from some of the Loop studies.
Yeah, Chris, I'll be happy to talk about the data. So I'm going to walk you about the Tidepool data that was submitted to the FDA to get clearance clearance for the Tidepool algorithm. So what Tidepool did, they wanted to improve access of the DIY that was used in the community and unregulated. So they conducted a large observational study called the Loop Observational Study. They wanted to look at usability, safety, efficacy, and psychosocial outcome of using the DIY. So in this study, they recruited about 872 participants with type 1 diabetes on insulin using either MDI or insulin pumps, and who were on the DIY or were willing to start DIY. And they observed them over a period of 12 months. But today, I'm going to show you specifically the data about 175 participants who were matching the intended user population of the Tidepool algorithm and also matching our intended user population for twiist. And that is people who were using Humalog and or Novolog, people who are age 6 and above, and people who were using the Tidepool guardrails 90% of the time. And that is a glucose safety limit between 67 and 110, and a correction range between 87 and 180. These are the demographics of this intended user population. They had a mean age of 23 years, an average mean A1C of 7.1%, and they were 11% who have previously used AID. And that is not surprising because we're looking, this study was conducted in 2019, between 2019 and 2021, where AID were still becoming a big thing here in the US. Again, you can see the rest of the demographic. It's consistent with other demographics of other studies prior to the FDA regulation about including more diversity in clinical studies. And then I want to show you here the outcome of this study. So over a period of 6 months, we can see that the A1C average, starting with an A1C average of 7.1, the end outcome was an A1C average of 6.7%, and that is 0.4% reduction. When we look at an average of 7.1, we know that this population was very well controlled even prior to enrolling into the study. Despite that, we were able to see an improvement of 0.4%. Again, this is a population that is well controlled at baseline, not using the twiist device, but using the DIY algorithm. And if we look at time and range, we can see an improvement of 8%, from 62 to 70% over a 6-month period. 8%, if we do the math, that means about 2 hours extra time per day being in target range. That time and range of 70% is consistent with what we see in a lot of studies using AID systems. Now, looking at the adverse event, I would say there was no diabetic ketoacidosis. There was in total 23 severe hypoglycemic events from baseline to 6 months. I do want to point out that unlike a lot of other studies, these studies did include participants who did have severe hypoglycemia prior to starting the study. They did not exclude those people. And then if we look at those severe hypoglycemic events, we can say that 92% of participants, in fact, did not have severe hypoglycemia up to a period of 12 months. And so the majority of the hypoglycemic event were actually experienced by the minority of people, and those are the ones who had hypoglycemic event prior to even being in the study. But even in those subgroup of people who had severe hypoglycemia prior to starting the DIY algorithm, they actually saw an improvement in severe hypoglycemia after starting the DIY. But looking at the whole group of the 175 intended user population, we can see that there was a reduction in severe hypoglycemic event from 192 severe hypoglycemic event per 100 person year to 42 severe hypoglycemic event per 100 person year. And that is 80% reduction in the incidence of severe hypoglycemia. And these are the data in addition to the results of the total loop observational study that Tidepool submitted to the FDA to get their clearance. And as you recall, in 2023, Tidepool got clearance of their Tidepool algorithm to be used as an interoperable algorithm.
Well, thanks, Joanna, for going through the clinical data there. That's really exciting to see the results that that Loop has provided over time. And so now we're actually going to transition and move from Tidepool Loop to twiist loop. And so I mentioned this a little bit earlier, but in case you don't remember, as a reminder, what happened is, so after Tidepool Loop got clearance through the FDA process, we partnered together, and basically what we've done is we've taken the Tidepool Loop algorithm, translated that into a different programming language, and actually embedded that within the twiist device. And again, why that is important, that allows people to not have to have their phone or their app near them to remain in closed loop mode. So really exciting feature and benefit of twiist as well. And as we look forward in talking about Loop, we've gotten a lot of questions about what patient types are right, who are the right people for Loop. And one of the things that we've really focused in on is truly understanding who would benefit most. And the exciting thing that we've come to realize is that twiist Loop really provides that flexibility and personalization capabilities for you to meet patients wherever they are in their journey. So with that said, let's dive into some of the basics of twiist and the algorithm and really focusing in on how twiist Loop can be used practically to help your patients.
Thanks, Chris. And I'm really excited to talk about the algorithm. I've been following this project for a really long time as someone living with type 1 diabetes. And I was so excited when the FDA cleared the Loop algorithm with Tidepool and using that data that Joanna was able to show us. So the algorithm is really not complicated. If we remember the origins of this algorithm, it was really meant to tell a traditional insulin pump how to make adjustments automatically. So the language of twiist is both familiar and intuitive for those who have used traditional insulin pumps. In a traditional insulin pump, the settings that you set are the scheduled basal rates, the carbohydrate ratio, the insulin sensitivity factor, and then there are delivery limits, both set for max basal rate as well as max bolus. The scheduled basal rates, carb ratio, and insulin sensitivity factors are all things that can be changed in order to help make the automation work better for your people with diabetes. The max basal rate is something that's important to keep in mind because our system is using basal modulation, and so that's going to need to be set high enough so that the algorithm can deliver enough insulin to correct for high glucose values. The twiist loop, in order to create an automated system, needed to have some goals in mind. So the correction range is the range in which the algorithm is constantly trying to focus the glucose into. And then that can be set anywhere from 87 to 180 milligrams per deciliter. Temporary correction ranges can be set for the pre-meal preset and the workout preset, and we'll talk a little bit about those in the future. The glucose safety limit, as Joanna pointed out, is 67 to 110. So this can be set as low as you feel comfortable for people with diabetes, and this kind of acts as a suspend threshold for our system. At the most basic level, you want to think about the algorithm as doing three different and distinct actions. The first thing it's going to do is forecast what the glucose value is. It's looking to make 72 glucose predictions every 5 minutes to create a 6-hour forecast. That 6-hour forecast is used in all of the insulin calculations that are going to happen in the future. It's going to automatically adjust basal insulin delivery every 5 minutes based on that 6-hour forecast, and it's going to be used as the basis for the bolus calculations that are user initiated. After it gives the insulin as it's described, it will recalculate again every 5 minutes and make a new decision on whether it's going to modulate the basal insulin. So let's talk a little bit about the settings that we were just talking about. So the glucose safety limit, as I said, can be set anywhere from 67 to 110. Again, this acts as the suspend threshold so that if the forecast is ever going to cross this threshold, we would actually see that the system will suspend briefly until the forecast comes above that level. The correction range can be set anywhere from 87 to 180. In this example, we have the correction range set from 100 to 115, and what the algorithm does is it uses the middle of that correction range as the mathematical target for glucose values. The range can be set as wide or as narrow as you, as the clinician, would like to, based on the person who's sitting in front of you. The pre-meal range is a temporary range that can be set anywhere from 67 to 130. This is very unique to the Loop system, and it allows some extra insulin to get started prior to when somebody starts eating their food. By setting this target lower, it may either increase the basal insulin to get the glucose to come a little bit lower than their target, or it also allows that if a person is in a lower range, say 90 milligrams per deciliter, they wouldn't get a reduced amount of insulin going into their meals, which is really important because we know we don't want less insulin in the system when the person is about to eat. And a workout range, just like in other systems, allows the target to be set higher. So this moves that correction range, in this case, high to about 140 to 160. And this can be set from 1 hour to 2 hours or indefinitely until the person shuts this off. And here's how this all works together. In this example, there is a correction range of 100 to 120, which makes the glucose target 110. What a person with diabetes is going to see on their screen is their current glucose and the CGM data leading up to this. And traditionally, this is all that a user would see on their AID system in the other AID systems. What's really nice about Loop, though, is that they can see the full 6-hour prediction that the algorithm is using to make dosing decisions. The 6-hour forecast is essential to determining the insulin delivery. So this is what that 6-hour forecast is going to look like on the person's screen as they're using the device. The forecast incorporates any active insulin that's been given. So this is going to say you have active insulin at 2 p.m. that's driving the glucose down at that point. And so the prediction might be impacted downward based on the active insulin. But you also have carbohydrates that might be active. So this is where we really shine as an algorithm. The carbohydrate entry shows that they're also going to have active carbohydrates at 2 p.m. So we're not just saying, oh my gosh, you have active insulin at 2 p.m., so you might get low at 2 p.m. It's also taking into account those carbohydrates, and which are going to be pushing up on that forecast. These are all taking into account the therapy settings that you set as the clinician. It's also making all of those insulin dosing decisions based on that glucose forecast and the therapy settings that have been input into the system. So let's talk a little bit about kind of simply how the decisions are made. So again, we talked about how the decisions are made based on the 6-hour glucose forecast. So in this scenario, we see that the current glucose is 110. However, this person must have enough insulin on board that at 2 hours from now, their predicted glucose is expected to be 60, which is below the glucose safety limit. What this situation is going to indicate to the algorithm is that the insulin delivery needs to be suspended. Again, it will be suspended for 5 minutes at least until the algorithm then recalculates that forecast and that minimum predicted glucose comes above that glucose safety limit. If the forecast doesn't go below the glucose safety limit, but the forecast ends up below the correction range, the algorithm will make the decision to decrease the basal rate in order to help increase this eventual glucose up. Again, this is all happening automatically. If a person sees that their glucose is down a little bit, they can be reassured that they are going to have a decreased insulin delivery to prevent that lower glucose. And if the glucose ends up higher than the correction range, this is when the algorithm kicks in and increases the basal rate. So in this situation, we can see that the eventual predicted glucose is 160. Since the correction target is 105, the algorithm calculates that this person needs enough insulin to bring their glucose down by 55 milligrams per deciliter. The example I like to give here is that if it's 1 unit that would drop someone 55 milligrams per deciliter, the algorithm is going to decide to give that 1 unit over a half an hour. So it's going to spread that as increased temporary basal rates over a half an hour in order to deliver that full 1 unit of insulin. And this is why that max basal rate is so important, because in order to deliver 1 unit over a half an hour, the basal rate needs to be able to increase by 2 units per hour. So it's important to consider that max basal rate. But if the person doesn't want to wait and they look down at their watch and they see that their glucose is high, and they say, I'd actually really like to get this down faster than delivering that insulin over a half an hour, they can initiate the correction bolus from either their watch or from the phone with these 2 orange arrows. And in that situation, the algorithm is going to calculate what that bolus needs to be. Same calculation as we did on the last slide, but the person's going to receive this insulin as a bolus. What happens with carbs? Well, this is really different than other systems. Because we're using those emojis to describe the absorption of the carbs that a person is entering, we're actually going to use that information to make dosing decisions for their bolus for meals. So in this situation, let's pretend that this person is eating a 10 gram of carb meal. It's a mixed meal, so they choose taco. And what the algorithm is going to do is it's going to first model what the glucose would do if all it was doing was absorbing those carbs. No insulin. This is what would happen if there was 0 unit bolus given right now. It then goes through a series of calculations to determine the best bolus to give up front, knowing that the algorithm later on is going to make up for any higher glucoses based on the extra carbohydrates with the basal adjustments. In this situation, the algorithm is going to calculate what would happen if we gave this person a full 1 unit bolus. And if we give all that insulin up front, the algorithm predicts that they would probably have a low glucose value within the first 2 to 3 hours. So the algorithm tries again. And it does more than 3. But in this scenario, we're going to just describe the 3 that it tries. And it determines that 0.75 is actually the right dose to give to cause no hypoglycemia, but not also causing a lot of hyperglycemia. All right, Joanna. So I just went through all this stuff, and I have a surprise for you. I need you to help me explain practically how people might use the reports to make changes that are impactful to the algorithm. So are you ready?
Sure.
Are you sure?
Go ahead.
Okay. All right, Joanna. So the first case that I'm going to throw at you is this case that we're seeing on the screen right now. What do you think you would do with this situation?
Great case, great question. This is a very pattern that we see very frequently and very simple. I love the visual, I love the colors. You see glucose rising between midnight and about 6 a.m. And you see at the same time that insulin is rising in parallel to modulate, like you just explained earlier. And in this case, all you need to do is simply increase your basal rate during that time of the day. And as you increase your basal rate, you would also in parallel increase the maximum basal rate. So the algorithm continue adjusting and modulating to keep your glucose within the correction range.
That's great, thank you. How about this one? This is a new pattern that you see on the patient that comes in. What do you see here?
Yeah, this is also a very similar pattern that we see in a lot of people with diabetes. Again, the first thing is we confirm that this is a pattern versus related to a specific meal. And as you can see here, there's a glucose rising right before breakfast, glucose is not rising after lunch, and there's a glucose rising again after dinner. If this is a pattern, I typically would increase the insulin to carb ratio before breakfast. I would increase it as well before dinner. Sometimes you may see that the timing of the correction bowl or the meal bolus was not given right before you see the glucose rising. In this case, I ask the patient to make sure they get the bolus 15 minutes before their meals.
And what would they say if you said that and they were like, I can never bolus 15 minutes before my meals? What would you recommend they can use within our system?
Yeah, I mean, first of all, like as people get more accustomed to our system, they can start using or taking advantage of the unique feature that the algorithm has to offer. So they can do quite a few things. One of them is they can, if they don't know what time they're going to eat, they can use the pre-meal preset. So if they say, I don't know what I'm going to be eating a little bit later, they can use that pre-meal preset. All they need to do is click on the icon to initiate that. Sometimes if they forgot to eat, they can retroactively take the opportunity of using the retroactive carb.
I love that. Yeah, that's great. Thank you.
Well, thank you both. It's great to see you both kind of geeking out over these case studies and bringing everything to life. So I hope everybody in the audience got some understanding of practical use and how simple it is to really do a lot of adjustments to make sure your patients are getting to the goals that you set as well as they set. So with that said, we're going to talk a little bit more about some of the other unique features of twiist. You know, I think we spent a lot of time talking about the clinical benefits and some of the clinical case studies. Just as a quick reminder, you know, we have a lot of other features that come with twiist that allow for that personalization and flexibility that we talk about. Really from the intuitive interface that was designed by that do-it-yourself community, really to make things as streamlined and simple to understand as possible. And additionally, as we talked about earlier, we're the only system that currently allows to bolus from the Apple Watch and to do a number of other settings and adjustments as well. So really driving home the convenience and simplicity of what you can do with twiist. And now we're going to transition to some closing remarks, and then we'll take a few questions as well. So before I give my closing remarks, I'll turn it over to our panelists to give any last thoughts that they have and want to share with you. So we'll start with Jean for some closing remarks.
Sure. As I said, I'm so excited for this algorithm to finally get into the hands of more people with diabetes. So I just can't wait to start seeing this and the results.
Yeah, absolutely.
Yeah, I would say, Chris, that at Sequel, we are not just making a new pump or a new AID system. We are actually bringing twiist to address and close gaps that exist currently in the technology. So our goal is to continue innovating to bring an AID system that provides flexibility, an ID system that provides you also with the option to be able to customize according to your needs, and also an ID system that is easy to adopt. We know that the ADA guideline has strongly recommended the use of AID system early on after diagnosis. And so we want at Sequel to be leading that effort.
Yeah, absolutely. So I think these two summed it up really well. For me, I'll just try to encapsulate it all. You know, we have a unique system that is going to provide broader access for people and allow more people to get access to an AID system in an affordable way. Hopefully today, through the session, you've seen the personalization and flexibility that the system offers and the transparency, not only for the patient, but also for you as a clinician. And we did touch on the technology as well a little bit today, and stay tuned for a future webinar that will be a deeper dive into that technology, where we really talk about the benefits of that faster occlusion detection and how the system works. So stay tuned for that. All right, with that said, I think it's now time to move into our Q&A portion. If anybody's been logging in here, let me just see what questions we have. Oh, we have quite a few questions actually, so I don't think we'll be able to get to all these, but we'll try to get some of the top questions here. Gene, I think this one's directed at you. Are you currently using the twiist system, and what has your experience been like?
Sure. So right now, I'm actually not using the twiist system, but I will be soon, very soon, as far as I know. I'm really excited to finally get to use this algorithm and the technology that is within the pump. So I'm just really looking forward to it, and I know it's coming really, really soon.
Yeah. All right, great. Let's see, what else do we have here? How do I view my patient's data? I'll take that one. So not only have we partnered with Tidepool on the algorithm itself, but they're also our partner for data management. And so anybody who's prescribing twiist will have access to unlimited twiist users in the Tidepool system. So that's our data management platform, and you'll find it super easy to use and helpful in managing your patients.
And actually, Chris, I'll just add that the reports that Joanna was showing, those are what they are kind of going to look like. So that's how they're going to.
So you got a little preview. So
exactly.
yeah, that's great. Okay, let's see here. What else? Joanna, maybe this one's for you. What is the maximum basal rate normally set to when you're starting somebody out with?
Yeah, great. We do recommend starting a maximum basal rate 2 to 4 times the set basal rate. Obviously, you could adjust that according to your patient's needs, but that would be a good starting point.
Yeah, great. Okay. Another question here about who is our CGM partner. This must have come from somebody who joined a little bit late. So our immediate CGM partner, as we recently announced in the last couple of weeks, is Abbott with their Libre Freestyle 3 Plus sensor. So that will be our initial partner out of the gates, but we believe strongly in providing patient choice, and so we anticipate working with all the major CGM players, and we're in active discussions and technology solutions with everybody. So we do expect to have additional CGM partners in the future. So stay tuned for more on that front. And let's see here. Then I think the last one that we have time for today, we get this a few times here, is when is the launch date? So I think that's probably top of mind for a lot of people. Just to let you know, we're going to be providing access to our internal employees to go on twiist first, and then we're going to kind of slowly expand there to a few more accounts, and then pretty quickly from there we're going to go to broad availability, and we expect that to happen later in Q2, and so stay tuned for more. You can always sign up at twiist.com as well, and we can keep you in the loop to let you know when it will be available in your area as well. And if you want to have a rep reach out and start to give you a more detailed demo on twiist so you can get started. So with that said, thank you very much for joining our webinar today. Again, this is the second in a 4-part series. We hope you walk away understanding that twiist is going to help you get more patients access to an AID system that is truly affordable for them. It's going to provide you the personalization and flexibility options that you need to manage your patients and to help them get to their goals as well as the goals that you set for them. And finally, we have a revolutionary, really, insulin delivery system that is going to offer some additional benefits in terms of earlier occlusion detection. So really an incredible package as you look what twiist offers. And so we look forward to hearing from you soon, and please stay tuned to our upcoming webinars. Thank you.